Good morning and welcome to this talk. I'm Saber. I'm a postdoc at the School of Psychology here at Sussex, and today I'm going to share our experiences of using automatic pose estimation models in infant studies. Motor development has been an interesting and important field of studies, and usually movement scientists and developmental psychologists use different techniques like manual coding and using tests and batteries, which are reliable, most frequently used. But these tests are subjective and time-consuming and need enough expertise. They also use sensors like accelerometers, gyroscopes to study movement in babies, which provide high-frequency data, but again, these sensors are sensitive to the sensor location and sensitive to the condition of the sensor. Usually, these are not user-friendly. It's difficult to install and use them in babies. And the data is complicated. They also use motion tracking systems, which needs to put markers on the baby's body and track them. These are, again, reliable methods, but the devices are expensive and are limited to the laboratory settings. And with advances in computer science, nowadays we can use markerless human pose estimation models, which are really compatible, especially with the home settings and natural settings. But again, these are sensitive to the recording conditions, and the post-processing analysis is complex. In BabyGrow study, BabyGrow study is a longitudinal study. We are going to receive weekly data from newborn babies up to their 8 months. So we asked parents to send us weekly videos of the babies, when the baby is in the baby suit on the mat, similar to this picture, then record a 5-minute video and send it to us. But instead, we received videos in a diverse range of conditions, uncontrolled conditions, and we had to decide which human pose estimation model is suitable for our study, and specifically with a large number of videos, more than 2K videos. We need a computer vision human pose estimation model, which has already a demo version to easily use in our study. It supports GPU processing trained based on COCO model. Is publicly available and compatible with large sample data, which we needed something to run on all of videos, because it doesn't make sense to run on each video one by one. Looking in the literature, we found that usually movement scientists use Deep Lab Cut and OpenPose, and recently MediaPipe. Deep Lab Cut was not based on our criteria, so we excluded from our study. We started our analysis using MediaPipe and OpenPose, but they were not satisfying. There were many frames with misdetections and wrong detections. So we decided to look for the most recent developed models, which have the higher level of accuracy based on their reports. They usually have more than 90% average precision. Then we chose 2640 frames of videos from 20 videos of 8 newborn infants. We manually annotated them using CVAT, and then we ran the most heaviest model from each of these human pose estimations on them and extracted the data. We calculated the accuracy, speed, and efficiency for each model. We used object key point similarity for accuracy, the number of frames per second as speed, and to make it easier to decide which model is better, we calculated the efficiency model based on a weighted measurement of each calculation. First of all, our results showed that the average precision level on infants was lower than what those models reported in their studies. The best model was Sapiens with about 50% average precision, which was lower than 90%. There was a very close competition between Sapiens and Vitpos, which Sapiens significantly had a better performance than the Vitpos, and the most accurate model was MediaPipe. We also showed that different models show different level of accuracy in different key points. For example, eyes were the easiest key point for most of the models to detect, and hips were the most difficult key points for all models to detect, which was interesting for us. In terms of speed, as we expected, MediaPipe had the highest speed with more than 4 frames per second, although it was much lower than they reported in their study. They said it should be like more than 20 frames per second for real time. And the slowest model was Sapiens with less than half frame per second. And considering all together, in terms of efficiency, it seems that these recently developed models, PCT, Sapiens, and Vitpos, have a very close competition, and there wasn't a significant difference between them. And the less efficient model was MediaPipe. In general, we can say that human pose estimation models seems to work on babies, but the accuracy is not high, as they mentioned in their studies. There are different reasons for these differences, which we have a poster in the poster session, so you are very welcome to come and look at the poster as well. And we would recommend researchers to use the most recent models in infantile studies. And also, we encourage researchers in the field of machine learning and AI to consider infants in training their future models. And also, I would thank to our BabyGrow team and Dr. Simpson for their help and insights for the system. Thank you very much.
Thank you very much. Do we have any questions?
Yeah, hi. I was wondering, short of kind of including babies right into the training set, was there a possibility to fine-tune those models with baby data?
Sorry, can you repeat it?
Is there a possibility to fine-tune the models rather than doing the first training, to include all the baby data? Can you take the trained model and train it again on some baby data to fine-tune it, like it's often done with
yes, exactly.
Models?
It is possible to do, but our aim was to use already provided models to be able to replicate for the other researchers, we just wanted to show how the most recent models are better than the previous one, because currently most researchers use MediaPipe and OpenPose, and the reason is these two are too much user-friendly. So it's easier for them. They just go and run their... it needs more steps to retrain the model and use for their study. But it's possible, yeah, definitely.
Yeah, thank you.